Extraterrestrial life refers to life forms that did not originate and are not indigenous to our planet. This term covers all possible types of life outside the Earth. These can be viruses, but also plant-like life forms. Some go even further. They are looking for creatures that are very similar to humans in their complexity or even surpass them, popularly known as aliens. But if there is extraterrestrial life, why hasn't anyone heard about it until now? Do so-called aliens even exist? The Fermi Paradox addresses this very question. What approaches there are to this, you can find out here. The Fermi Paradox represents a thought of the physicist Enrico Fermi from 1950. Fermi assumed that there is extraterrestrial life or extraterrestrial intelligence. This extraterrestrial intelligence should make it possible for technically advanced colonizations to survive for several million years, and during this time, it should be possible to colonize complete galaxies by means of intergalactic and interstellar space travel. Fermi went even further. He assumed that this had already happened. Nevertheless, the search for extraterrestrials has been unsuccessful so far, which was paradoxical for the scientist. Therefore, he questioned his observations and assumptions, which led to the Fermi Paradox. Since the universe is already very old and has many stars, there should be life beyond the Earth, unless the origin of life on our Earth is an unusual process. This is also called the rare Earth hypothesis. It is assumed that the Earth does not have a unique position in our solar system, and that there are other technical civilizations in our galaxy. Although the galaxy has a width of about 100,000 light years, a sublight drive would need up to 10 million years for such a distance. So that one can conclude that the age of the galaxy is about 10 billion years. If there is a civilization in the Milky Way that is capable of interstellar colonization, then the whole galaxy could be completely colonized, and that only in a few million years. But the Milky Way is much older than the at least 20 years that would be necessary for it. Therefore, extraterrestrial life should exist somewhere in the neighborhood of the Earth, but up to today, no proof for extraterrestrial life could be found. So the paradox in a nutshell: if extraterrestrials do exist, why aren't they here? The Drake equation, closely related to the Fermi Paradox, is an attempt to estimate the number of extraterrestrial civilizations in our galaxy. However, most of the parameters of this equation are still unknown, so it cannot help much in solving the paradox. The Drake equation only refers to the Milky Way, our galaxy. The Milky Way is a barred spiral galaxy, according to whose type about 2/3 of the galaxies existing in the universe are constructed. Since the universe, as observed today, has about up to 100 billion similar galaxies to the Milky Way, the final value resulting from the Drake equation would have to be multiplied by a relative factor for the whole universe. Although this increases the total number of possible civilizations enormously, this calculation remains very imprecise due to the insufficient knowledge of other galaxies. Furthermore, the Drake equation refers not only to the theoretical number of civilizations, but also to the possibility of establishing contact with them. The closest galaxy is the Andromeda Nebula, which is 2.5 million light-years away. So this galaxy is already out of consideration for practical contact, and consequently all others as well. Hypothesis: we are really alone. One thesis says that multicellular life in space is very rare, since even Earth-like planets are rare. Since many improbable coincidences met each other so that life on Earth could develop, the existence of other Earth-like planets is also improbable. These coincidences include the existence of the Moon and the position of the Earth in the solar system, which ensures a life-friendly temperature for the Earth. In this explanatory attempt, the parameters of the so-called Drake equation are chosen in such a way that in the galaxy in which we find ourselves only our civilization exists. Thus, the Fermi Paradox no longer becomes paradoxical because one of the basic assumptions is negated. This hypothesis is convincing for many scientists. However, there are scientists who believe Earth-like planets do exist. Especially the fact that more and more exoplanets are being discovered supports this assumption. Impossibility of interstellar colonization. The prerequisite for the Fermi Paradox is a civilization capable of colonizing interstellar space. However, this cannot be fulfilled on principle. With this precondition, it would be possible that there would be some technical civilizations, but they could not influence each other due to the vast spatial distances. Here is an example. The distance from the Sun to the star Proxima Centauri, the nearest star, can only be reached after several years, even if the speed of light is included. According to current knowledge, however, the speed of light cannot be exceeded. This leads to several questions. First, the question arises whether a civilization could still reach foreign star systems, and if this would be advantageous for this civilization. On the other hand, there is the question of what time offset in oral exchange among populations from different star systems would be acceptable for a civilization to have the necessary cohesion. According to Stephen Hawking, the origin of life outside the Earth is probable. He also believes that human-like intelligence is possible. However, he assumes that this intelligence will eventually reach a limit and become unstable, so that these organisms will unintentionally extinguish themselves. This could be triggered, for example, by genetically manipulated viruses, nuclear wars, or a greenhouse effect that can no longer be controlled. Berserker theory and dark forest theory. The Berserker theory, named after Fred Saberhagen's Berserker saga, assumes that aliens send artificial probes into space that destroy other civilizations. In doing so, they deliberately eliminate other life, allowing the aliens to spread out into space undisturbed. There are different opinions concerning the way of extermination. The dark forest theory, named after Lou Sixon's trilogy, The Dark Forest, aims in a thematically similar direction. According to this theory, extraterrestrial life does exist, but these civilizations camouflage themselves and behave inconspicuously. This is intended to reduce the risk of predation, similar to camouflage in biology. According to this view, the universe is a so-called dark forest, home to all kinds of predators competing for the best camouflage. Astrophysical explanation. Cosmic ray bursts are now considered the most energetic phenomena in the universe. Gamma-ray bursts can cause mass deaths on planets located within their cones of radiation, even light years away. Thus, higher life could also have been extinguished by them in galaxies. Evolution into complex life forms is believed to have been impossible in the first 5 billion years of the universe due to intense gamma-ray activity. The mathematical a priori argument. Astrophysicist J. Richard Gott does not find the thesis of galaxy colonization tenable. He believes that all life would then be part of such a super-civilization. According to him, if civilizations existed, it would be unlikely that we formed on the comparatively young and small Earth, which hadn't even been colonized at that time. The Great Filter concept. The concept of the Great Filter combines some of the above arguments. This concept suggests the existence of a filter that is necessary to reach a certain level of civilization. This filter would pose a significant hurdle or challenge that makes reaching that level very difficult. It's possible that higher intelligence is exceedingly rare in evolution. Under this assumption, humans would be the only life form that has overcome the Great Filter thus far. Another possibility proposes that as civilizations spread and develop, certain factors inevitably lead to their eventual extinction. In this scenario, other civilizations may have failed to overcome the filter, and humanity might be the first to do so. Natural philosophical approaches to the existence of extraterrestrials can be found in antiquity. In Plutarch's work, Das Monkschicht, thoughts about life forms that do not live on Earth can be found. However, these texts mainly refer to mythology, and it's unlikely that they aim to develop rational arguments about extraterrestrial life. Another challenge in astrobiology is the lack of a general definition of life. Despite various attempts, no definition has been universally complete or satisfactory. This could suggest that there's no clear-cut distinction between living and non-living. Additionally, even if life similar to Earth's were found, it would need to be determined whether it originated on Earth and spread through space or developed independently elsewhere. What do you think? Do you believe that humanity and Earth are unique in the universe, the result of an extremely improbable coincidence? Or are you a science fiction enthusiast who already holds detailed ideas about the appearance, way of life, and planets of potential extraterrestrial life forms? The topic of extraterrestrials will undoubtedly continue to captivate the scientific community for a long time. Feel free to share your opinion in the comments, and perhaps you have an innovative approach to solving these mysteries.